Practice 5, Jominy test, team number 5, conformed members, Didier, Joaquin, Ramon, Salvador, and Edgar. The objective of this practice is to make a Jominy test in order to test the hardenability of carbon and low alloys and apply the results for selections of steels and applications. For the practice, we will be using a Jominy test prop of 1045 steel. For the equipment, we will be using a Jominy tester, an electric oven, a security equipment, a Rockwell harness tester, and a surface grinding machine. And we will be using some tools as the copper sulfate.
The procedure of this practice was sinking our piece into a copper sulfate in order to have like a skin in our piece, and then dry it with air. After this, we have to introduce our piece into the oven and wait for by 35 minutes before take it out. And once that the 35 minutes was passed, we have 5 seconds to take it out and put it in the Jominy's tester. Well, once that we have the piece into the Jominy's tester, we have to wait 10 minutes, more or less, in order to get the heat treatment finished. After this, we have to use the grainer machine in order to have this line and can use the Rockwell harder test. Once that we have our piece prepared to put it in the Rockwell hardness test, we have to make an indentation every 1/16 of an inch. So after the whole procedure, we have 32 indentations.
The hardenability of a steel is how easy we can harden a steel by quenching and producing martensite. The severity of a temple relates to the cool rate. Doing a bigger cool rate, the bigger the severity it has to be. The real critical diameter refers to when cooling the rod on a temple environment to make 50% of martensite. On the ideal critical diameter is the same, but on infinite temple environment. The perfect quench is when it occurs immediately. And finally, the correct temple is when the actual temple relates with the cooling rate.
To calculate the critical diameter of a steel, we have to know the grain size. To get the diameter, we have to do this formula, that is DI equals DI Jominy. The DI Jominy is the percentage of carbon that the steel has. For our test, we had a 1045 steel, so we only have carbon in it, and we go in the table, that is this one, with the percentage of carbon we have, and the grain size, that is 7 or 8, and we obtain at 0.2259 or 0.2090 inches of diameter. The ASTM for Jominy test is the designated A25502, that is the standard test methods of determining hardenability of steels. It describes the two ways that we can get the hardenability. One is the quench test, that is the Jominy, and the other one is the one made by M.A. Grossman, which is how we get the hardenability by the chemical composition.
The Jominy curve describes how the hardness decreases among the material because of the cooling rate. The material presents a higher Rockwell number at the beginning because it's cooled instantaneously when it touches the water. In here we can see our first test, that is 45, where is the martensitic reaction, and in here we can see the curve that is decreasing because of the material is cooled lower in the proof 32, where is cooled by a lower rate. With the result that we obtain of the practice are similar for the results that we investigate in internet.
The cooling rate is the amount of degrees of temperature that are reduced from an object with respect to time. In the Jominy test, the cooling rate is related to the distance from which the water is in contact with the probe. If we want to know the cooling rate of the object at 25 millimeters or 1 inch, we can just simply look at the graph and we can see that is 5.6 degrees Celsius over second, or 10 degrees Fahrenheit over second. The hardenability of the steel depends on two variables, the grain size and the composition. The hardenability increases with an increasing grain size because the gram boundary area decreases, and this means that the nucleation of ferrite and perlite reduce in number, and therefore the transformations slow down and the hardenability is increased. The amount of carbon has a direct relation with the hardenability. The higher the amount of carbon, the higher the hardenability. However, we cannot put a lot of carbon in an alloy because the toughness is compromised. So we want to achieve a balance between hardenability and the amount of carbon. We have to include other alloying elements such as magnesium and chromium. So if we want to know which is the steel that has better hardenability, is one that has high amounts of carbon, but complemented with alloying elements as magnesium and chromium.
I conclude that the Jominy test is very helpful for mechanical engineering because by this way we can know to produce martensitic reactions by putting the material in water, and also to see the hardness of the material.
It is important for a mechanical engineer to know how to manipulate this quenching to make martensite, and where we can apply it on the industry. So I think it's a very interesting practice that we will be using in our future.
Yanni.
In my conclusion, I think this practice was helpful and really interesting because we learned to use the Jominy test and how it is done. And I think we can use this knowledge further because if we need to know the exact quenching temperature and how it will act, we can obtain certain properties that in industry are required.
Well, my conclusion of this practice is that there are many heat treatments that involve some liquid solutions and some devices like Jominy's device in order to get or to make harder a material. So this will be helpful for us as mechanical engineers when we have to improve the hardness of a material that we are working with.
I think that the Jominy test is important to understand the martensitic reaction in extent and to determine which steel is useful for a specific application depending on the mechanical properties after the Jominy test.